This is the third video for section Stsd F. Now, values from the normal distribution areas table that you can find in the appendix of your book enable the determination of proportions of the data set that lie above a raw value, below a raw value, or even between two raw values within a data set. Now, a quick sketch is the way to go because it'll help you figure out exactly what you're calculating. Okay, so you should reshade the required area and then use it to work out what the required calculations will be. Now, when working with raw scores, the first step is to convert to Z scores so we can use that normal distribution table. So let's look at some examples. The weights of chips in packets have a mean of 50 grams and a standard deviation of 3 grams. Find the proportion of a packet of chips with weight between 50 and 52 grams. So let's write down our information. Mean is 50, standard deviation is 3. If I draw a picture, my mean is here, and it's saying between 50 and 52 grams. So 52 is here. We want that area there. So it is just the area above the mean. Now my first step is to work out the Z score for that 52. Now my formula is X minus the mean over the standard deviation. So that's going to be 52 minus 50 all over 3, which gives me 0.67. I then go to my table, my normal distribution table, and I look up what a Z score of 0.67 refers to. And if you have missed the last video, go back and read that because I go over reading the table. But you get the proportion is 0.2486. So that's from the table. So then we finish with the therefore statement. Therefore, 24.86% of chips weigh between 50 and 52 grams. Okay, so if you're not getting how I've got this value here, go back and rewatch the last video that I show how to read the table. Okay, next, find the proportion of packets of chips with weight between 47 and 50 grams. So here, draw a picture again. Mean is in the middle, which is 50. 47's below. It doesn't matter where I put that line. I just want to know where my area is. So now it's below the mean, but because I'm looking at symmetry, I can just read what the value is from above. So Z of 47 is going to be, I'm not going to write the formula out again because you can see it over here. So I've got my score, which is 47, minus my mean, all over my standard deviation. And that gets me -1. So I'm 1 standard deviation below the mean. Now you might recall from when we were looking at our areas on either side of the curve that 1 standard deviation above or below is 68%. So you might realise that my answer is actually 34%. If you go to the table though and look up a Z score of -1, you'll get a proportion of 0.3413, which is approximately that 34%. Finish with a therefore statement. So you have therefore 34.13% of chips have a weight between 47 and 50 grams. Next, find the proportion of packets of chips with a weight greater than 55 grams. Again, draw your picture. The mean was in the middle of 50. Say this is my 55. So now I want this area here greater than 55. Remembering that our mean was 50 and our standard deviation was 3. So our Z score for a score of 55 is going to be X minus the mean over the standard deviation. So 55 minus 50 divided by 3, 5 divided by 3, or 1.67. Now I want all this area here. So let's look at our table for 1.67 as our Z score, and we get a proportion of 0.4525. But that's the area in here. This area here is right sideways 45.25%. Okay, I want this area. So the required area equals 0.5 minus 0.4525, noting that all of this is 0.5, the whole thing. So we subtract from 0.5 and we get 0.0475. Finish with the therefore statement. So we have therefore 4.75% of chip packets weigh more than 55 grams. So hopefully seeing these pictures really help. So here we have find the proportion of the packets of chips with a weight less than 45 grams. So if we draw a picture, here's my 50. Let's just say 45's here. So in this case we want that area. Okay, now my z-score for 45 is going to be 45 minus 50 all over 3, which is negative 1.67. Now do you note that it's just the other side of the mean from there? So you could just realise that. Go your proportion's going to be 0.4525, and then just go required area must be 0.5 minus that, but you've already worked it out as 0.0475. So therefore 4.75% of chips, or of chip packets, weigh less. Okay, so these diagrams are really important because you know that your table's giving you the proportion between the mean and the value. So you need to note that this value here is 0.5. You have to use that information. So let's look at the next one. Find the proportion of the packets of chips with a weight between 45 and 52 grams. Again, draw a picture. I might move it over a bit. Okay, my 50 is in the middle, so 45's on that side and 52's on that side. Doesn't have to be to scale. So here I have both sides of the mean. Okay, so what I'm going to have to do here is look at the two areas and add them together. Okay, where this is 50 and this is 52 and this is 45 and this is 50. So from this diagram here I can see that I've got two different areas to look at. Okay, so now let's work out a z-score for both of them. Z of 45 is going to be 45 minus 50 divided by 3, which gives me negative 1.67. And my proportion from my table is 0.4525. My z-score for a score of 52 is 52 minus 50 all over 3, which gives me 0.67. Look that up on your z-score table. Sorry, your normal distribution table. I keep calling it z-score table. So I've got my two proportions. So area is going to be 0.4525 plus 0.2486, which gives me 0.7011, or 70.11%. So finish with the therefore statement. So you've got therefore 70.11% of packets weigh between 45 and 52 grams. Next, find the proportion of packets of chips with a weight between 52 and 55 grams. So let's draw a picture. Here's my 50, so 52, 55. So now I want this area here. Now this one's a little bit trickier because you're going to have to do it in two steps. You're going to have to look at this whole area here between the 50 and the 55, and then you're going to have to subtract the area between 50 and 52. Okay, so let's look at our z-scores. Our z-score for 52, I'm just going to see, I've already worked it out there, so that's 0.67. Our z-score for when I had 50 for 55, I worked out previously as well let's go to a previous screen. So there's that 1.67 there. So save me working them out again. So I get 1.67. So my proportions for 52 was 0.2486, again just from there, and my proportion for a Z of 55 was 0.4525. Okay, so to work out our area, we need to go this whole area, all of this yellow, 0.4525 minus the bit that now looks green, 0.2486, and we get 0.2039. Finish with a therefore statement. So you have therefore 20.39% of packets weigh between 52 and 55 grams. Next, let's look at a different kind of question. If the company selling the chips rejects the 5% of the chip packets that are too light, at what weight should the chip packets be rejected? So in this case, here's my curve. There's my bottom 5%. I need to know what that score there is. Okay, now using my table, I only can look at the values between the mean and the z-score. So that's my z-score there. This is my 5%. So that means this area in here is 45%, or 0.45. So now I go to my table, my proportion is 0.45. So I look up my table and that gives me a z-score of 1.645, or it's between 1.64 and 1.65, so 1.645. I'm below the mean, so I have to put in the negative, so negative 1.645. Now it wants to know the actual value, so my mean is 50 grams, my standard deviation, is 3 grams. Or you can use your population. Probably go populations. We're looking at all the chips here, so it doesn't really matter. You won't get marked down. So that means x equals our mean minus our standard deviation times by our z-score. So that's going to be 50 minus 3 times negative 1.645, which is approximately 45.065. Finish with a therefore statement. So you have therefore packets weighing less than 45.065 grams should be rejected. Next, between which weights do 80% of the chip packets fall? So if we think of our curve, 50 is in the middle, so that's my 80%. Okay, so again my mean is 50 grams, my standard deviation's 3 grams. So to look at this area here, we have to look at each separate area, and each of those areas is 40%, or 0.4. That's our proportion. So go to our normal distribution table, and for proportion of 0.4, z equals 1.28. We're going to go plus or minus 1.28 because we want above and below the mean. Okay, so there are z-scores. To work out our x value, that's going to be our mean plus our standard deviation times z, and we're going to do this twice. So we're going to have 50 plus 1.28, standard deviation first, doesn't really matter, 3 times 1.28, or our other value is going to be 50 plus 3 times negative 1.28. So for this one we have 53.84, and here we'll get 46.16. Finish with a therefore statement. So I've got therefore 80% of packets lie between 46.16 grams and 53.84 grams. Last example. If there are 80 packets in a vending machine, how many packets would be expected to weigh more than 55 grams? Go to our curve. This is 50, 55. So the area we're looking at is this here. Okay, so what I'm going to find is this area here and then subtract it from 0.5. So my z-score for 55 is 55 minus 50 divided by 3, which is 1.67. Look up my normal distribution table. That gives me a proportion of 0.4525. So the area is 0.5 minus 0.425, which gives me 0.0475. From there, I need to work out how many packets out of 80 weigh more than 55 grams. So now I need to go number of packets equals 0.0475 times by 80, which is 3.8. Finish with the therefore statement. Now you can't have 3.8 chip packets. Would you round up or would you round down? Well, you're at 3.8 packets. If you round up, you're actually a little bit less than 55 grams. So technically you should round down, but it doesn't really matter. If you go approximately 4 chip packets and always round up, that's fine. Okay, but explain how you're doing it. Practice time, Stsd F2 exercise in your textbook. Quite a few questions because we have covered quite a lot.